this video, we'll learn how to interactively plot mean variance frontiers. So we'll interactively plot mean variance portfolio frontiers. As a starting point, let's initiate our mean variance portfolio object. Let's name it MVP spec, and as we have been doing, we'll use this portfolio spec function to initiate this object. Next, we need to specify the number of frontier points. These frontier points will be used to specify how many frontier points are required, and we'll use this MV spec object, MVP spec object, and we'll assign 100 frontier points. Now finally we'll create our frontier objects. Because we are using long only constraint, we'll name it long frontier. Let's name it long frontier, and we'll use portfolio frontier function. First we'll specify the data object, which is final underscore return, and we need to provide our minimum variance portfolio spec. Now that we have created this long frontier object, let's print it and see what is inside this object. So we can see that it has basic portfolio slot with estimator, solver, optimization, long only constraint, and notice out of 100 there are total 100 points. Out of those 100, it will be giving us 5 points to as a brief summary. So notice portfolio weights, point number 1, 25, 50. So we have every 25 interval, we have the details of weights. We have covariance risk budgets for each of these 100 points, but here for presentation purposes only 5 points are printed. We also have target returns and various risk, covariance, C-var, var risk printed for 5 points out of 100. So let's start. So let me enlarge the plotting window, and we wanted to plot it interactively. So we'll plot this long frontier object. Let's plot it, and once I click Control Enter, once I press Control Enter, 8 options are provided. So in the first option, it will plot the frontier object. Notice the frontier object is created. Then we'll add the minimum risk portfolio with selection 2. That red point is the minimum risk portfolio, it is added here. With number 3, we'll add this tangency line. So this is the tangency line, and this is tangency portfolio. Also with point number 4, we'll specify the risk return of individual assets. So all the 7 assets are there printed. So here we can see individual assets being printed. With the next selection, we'll add equal weights portfolio. With selection 5, we'll add equal weight portfolio. This is the square solid blue point here, which is the equal weighted portfolio. With number selection 6, we'll add 2 asset frontiers, combination of basically combination of 2 assets. A large number of 2 asset combinations as they are being created. We can see that line by line a number of 2 asset combinations are created. Next, with point number 7, we'll add Monte Carlo simulated portfolios. These dots represents a number of simulated Monte Carlo portfolios with different combinations of weights and so on and so forth. You can see these small dots representing Monte Carlo simulated portfolios. Lastly, we'll add Sharpe ratio of Monte Carlo. So with point number 8, we'll add the Sharpe ratio line. So notice this dotted line here, Sharpe ratio for Markowitz portfolio only. So this is Harry Markowitz portfolio Sharpe ratio. To summarize, in this video, we created interactive portfolio of efficient frontier and feasible region plot. In this plot, we started with plotting the efficient frontier, then we added minimum risk portfolio, then tangency portfolio, then we added risk return of single assets, then we added equal weighted portfolio, then we combined all possible 2 asset combinations to create 2 asset frontiers, and then we added Monte Carlo portfolios, simulated portfolios. In this particular video, we are working with long only configuration, so none of the assets are put in short position. In this video, we'll again create the long frontier plot, but in a more customized manner. So we'll again create the portfolio frontier, but in a more interactive and customized manner. So let's see. So we'll start with our frontier plot object, and here we'll use our long frontier object that we created in the previous video. We'll specify the type. We'll specify the type as line, and we'll add line width as 4, which will result in a very solid line in our portfolio. So we'll run this command and a very large efficient plot appears. Then we'll add the, you can say, CML point or tangency point. Again, we'll specify the long frontier object. We'll provide color as red, and we'll add PCH 19 kind of figure for plotting, and line width of 3, LWD of 3. So notice this solid red circle has appeared as a tangency point, CML point, or you can call it tangency point or best portfolio. Then I would like to plot equal weight points with equal weight portfolio. So equal weight points, again same objects are supplied, only that we'll change color to probably brown, and maybe PCH as 20 this time to change it a little bit. So this brown circle is supplied here. We can see that this is our equal weighted points, point representing equal weighted portfolio. There are certain combinations. Next, I also wanted to plot single assets individually. So I'll supply single asset points. So I want to identify single asset points as well. So I'll provide long frontier, PCH as specified at 20, but this time around I want to plot multiple colors. So I'll use color equal to 1 to 7. So 7 different colors will be employed, and sex equal to 3 indicates large circle. So let me start plotting from here. So when I add this, notice a number of colors appear. So these are my 7 assets. I also wanted to draw 2 asset lines as we did earlier with interactive plot. Here we'll do it in more customized manner. So 2 asset lines, but this time I'll supply specific colors. So probably I'll specify color equal to blue. Let me see. So here color equal to blue. So I'll run this 2 asset line command, 2 asset lines, and I'll supply my long frontier object, long frontier object. Let's see if, so these lines are created. You can see the lines being created. Let's see if we can specify the color also. So let me give a color of maybe blue. I'll empty this chart. Working, so I'll again recreate these. Okay, so blue color lines are being created, as we can see. In fact, here if you want, you can increase the line width slightly large so that the width of the line can be increased. LWD can be specified as 2. So you can see now again the lines are redrawn with a solid larger width. Also you can add Monte Carlo portfolios. Or first let's try with Sharpe ratio lines. So if we can plot Sharpe ratio lines with again the long frontier, but this time I'll provide color as red. For Sharpe ratio line, color as red, line width again will keep 2. So you can see a very solid line which is sort of going from here is plotted. Now let's add Monte Carlo portfolios also. So I'll add Monte Carlo portfolios, Monte Carlo points. Each point represents a combination of securities for a given risk and return. So I'll use long frontier. Let's use PCH of 20, and I'll use maybe color green. Let's use green color. It seems less green, so we'll use green colors to present Monte Carlo points. And you can see these filling our feasible region filled with Monte Carlo points. So to summarize this video, we created a customized frontier plot where we started with the frontier plot using our long frontier object created in the previous video. Then we added the tangency point with CML points command. Then with equal weighted points command, we provided the portfolio with equal weights in all the 7 assets. Then we identified the 7 single asset points. There are 7 assets in this portfolio that we are using, 7 securities we are using. So with this single asset points command, we identified all the points in this region. Then we also created two asset line as a combination of two portfolios. Then we added Sharpe ratio line, and then lastly we added Monte Carlo points. In this video, we'll examine the properties of our frontier point plots. More specifically, we examine the efficient frontier points and their weights, the weighted return of individual assets, and covariance risk budgets. So here we'll identify the properties of frontier points. Now, initially we started with the object with 100 frontier points. However, it would be slightly difficult to visualize 100 points in one graph. So rather what we'll do is we'll set n frontier points, but instead of using very large number of points, we'll restrict ourselves to maybe 25 points. And recall the name of the object in the previous video, it was MVP spec. So we'll use the same MVP spec object and we'll specify that we want to use only 25 points instead of 100. So now the specification is changed. So we'll again modify our long frontier object, which we have already created, but we need to modify it with the new frontier point values. So we'll specify our return object, final return, which contains the security returns or individual asset returns, basically all the 7 assets, the returns, and then we'll supply our modified spec object. So long frontier object is created. Now with this object, we'll do the weights plot. So we need to use this weights plot command, and we need to supply our long frontier object. Let's run this. So notice in this weights plot command, we have weights, and on the x-axis we have target return, on the top of it we have target risk, and we have unique combinations. So there are 25 points or portfolios. For each portfolio we have target risk and target return printed here, and their weight out of the total 100%, or this one represents 100% and there's 0. So their weights. So notice that the first portfolio with a return of 0.00581, here we have it seems DAX, and then as we move ahead the proportion of this DAX security goes down, and in between we have S&P and Nifty security, and last one seems to be Russell. So how the portfolio weight changes can be easily visualized, and also we can see how the movement of risk takes place. So return, here we can see return increases and also the risk increases. We can see that for all these 25 frontier points that we have specified. Next, we can also plot the weighted return plot. So for that we need to add weighted returns plot, and again we'll supply this long frontier object to this window, and we can see weighted returns, that means contribution to overall return by each asset is provided. Again on bottom and top we have target return, target risk, and we can see initially we have this DAX object, and as we move ahead in between we have this Nifty and S&P objects increasing share of in the return, as we can see on the weighted return axis, and last one is Russell. Finally, we also plot our covariance risk budget plot. In the covariance risk budget plot, we need to provide our long frontier object, and we can see the overall covariance risk budget 100%, that is 1. In the first portfolio, as we expected, we have the DAX object completely and its return and risk, and as we move ahead the risk contribution, as we decrease the weight of DAX, the risk contribution also decreases. In between we have Nifty and S&P significantly contributing to portfolio risk because we are significantly investing in these portfolios or assets. Lastly, in the last portfolio we have Russell 2000 only. To summarize, in this video we visualized our portfolio object with 25 frontier points. We visualized the weights for each of these 25 frontier point portfolios, the weights of individual assets for all the 7 assets. We noted that mostly it is DAX, Nifty, S&P, and in one portfolio Russell contributing. We also noted the weighted returns plot. We visualized the weighted return plot, and lastly we saw the contribution to the risk of overall risk to individual assets through covariance risk budget plot. In fact, if you like, you can visualize them in one window only. For example, you can use this par m fro equal to C3, 1, and let's enlarge our plot window. Let's see. So this entire plot can be visualized in one window itself using Power Info, and nicely visualized. We can see the movement of weights, weighted returns and covariance risk in a single window with each other. In this video, we'll initiate a short portfolio object and visualize it. So as a starting point, let's initiate our short portfolio object. Let's call it short. We'll initiate and visualize a short portfolio object. So as a first point, let's start with this short spec object. Again, we'll use our portfolio spec command to initiate the object. Once the object is initiated, let's assign some frontier points. So first we'll assign using this asset and frontier points command, as we did earlier. We'll simply put short spec and we'll start with 100 points first. And now that we have assigned 100 points, also please remember, when you're working with short objects where minus infinity to plus infinity all options are on table, you need to change the solver also. So we'll set using this set solver command. If you print this short spec object, notice the current solver configuration is solve quad programming. Now we need to change it, and using this set solver, we'll use short. We'll change it to short solver. We'll supply our short spec object, and we'll supply a solver name which is solver short exact. So this is our solver object, solver short exact. Now that we have identified the solver, we'll start with our portfolio object, which is short. Let's name it short frontier, and again we'll use our portfolio frontier function. We'll provide the return object data which is final return, which contains the return of 7 securities that we are using. Then spec, which is short spec object that we started. And lastly, we can now provide constraints as short. So we'll run this. Now our short frontier object is created. In fact, you can print it to see what are inside. So we can see now the portfolio weights. We can see some of the weights are negative. Out of 100, 5 points are printed, as we have seen in the previous video. Notice this solver short exact, and you can see some of the portfolios have negative. In fact, in covariance risk budgets also we can see some negative. And target, we can see the target returns, covariance, C-bar and bar risk calculated. Now using a very interesting command which is called tailored frontier plot, we'll try to visualize this short object. So we'll use this, what we call tailored frontier plot, which nicely prints a graph or plot of short frontier. So we'll use this short frontier object that we created. Let's give it a heading m text, which is MV portfolio with short constraints. Again, we'll stick to the covariance risk equal to cov. Now let's enlarge the plotting window so that graphs turns out nicely, and we can see here. Let's examine the graph. So we have a nicely printed frontier along with the tangency line, and we have also individual assets plotted here along with the Sharpe ratio line. So this is the complete graph through tailored plot commands. We can also use plotting commands that we used earlier to visualize this. In addition, we would also like to have those weighted returns, weights and covariance risk budget plots. So for that, I'll again use the same set of commands, copy paste them, but I'll just change this long frontier to short frontier. So I'll just change it to long frontier to short frontier. and let us plot them. I'll use this PAR-MFRO 31 so that all of them are there in this single plot. So let me zoom it to visually examine it more carefully. So let us examine this graph more carefully. In the first plot, we have weights of individual assets, and now we can see it varies from 0.0058 to 0.0451. We can also see how the weights are changing. Now see, it is negative -1. We can also see some of the points below -1 and some of them above 2, which indicates that some of assets has been shorted and the additional wealth due to shorting is invested in other assets. So we can see that. In fact, it seems that Russell has been shorted, maybe a little bit of FTSE also, and on the long side we have probably FTSE, FTSE and DAX on the long side, and the pattern moves gradually. On the weighted return plot also we can see the contribution. In fact, we can see some of the assets contributing negatively, particularly the Russell, and along with Russell maybe it seems CAC. Some of them are contributing negatively to the returns. Along with, we can also see along with that target risk and target return. In the last plot we have covariance risk budgets, and again here also some of them are contributing negatively due to their short positions, while more specifically the FTSE and DAX are CAC and DAX are contributing. FTSE and DAX are contributing positively, so they are in the long position initially, and the position varies over time. To summarize this video, we initiated with a short object with 100 frontier points. First we plotted these frontier points along with their frontier, then tangency line and individual asset points through tailored frontier plot command. Here we plotted them, and then also we visualize their weights, weighted returns and covariance risk budget plots for this short portfolio object. In the series of next 4 videos, we construct and visualize box, group and covariance budget constraint portfolios, and in the final 4th video we'll create a complex portfolio object with all 4 constraints put together. So first we'll start with the box constraint portfolio frontier. Please note, when you put constraints in the frontier is slightly restricted, not as free as the frontier printed earlier, which means that some of the combinations of risk return portfolios may not be available. So let's start with this box spec, let's call it box spec, and we'll again initiate with the portfolio spec object. Let's have it for set n frontier points. Let's start with 25 points. We'll start with. So we'll have this box spec object with 25 points, and let's specify the box constraints. So let's have C. First constraint may be minimum weight for portfolio 1 to 7. For let's put it on all the 7 portfolios equal to 0.01 as minimum constraint, and let's also put the maximum weight constraint for all the 1 to 7 portfolios equal to 0.5. So these are our box constraints. Now let's create this box frontier object, and this requires this portfolio frontier function where we'll specify the data as final underscore ret, and we also need to provide the specification of this, which we have put as box spec, and then constraints. So now that we have specified box constraint, we can directly put our box constraints object. So we have box frontier. Now as a starting point to visualize this, or you can directly print this also, you can just print this simply and you'll find all the constraints we have already discussed in the constraint video topic on constraints. 5 points are printed. You can see that their target risk returns are also computed, covariance risk budgets and portfolio weights are computed. You can see the constraint minimum weight and maximum weight. These are box constraints on individual assets. So let's use this tailored frontier plot and let's specify the object. Our object is box frontier, heading is mean variance portfolio with box constraints, and again our risk is covariance risk. So let's plot this. So we need to enlarge the window a little bit, and you can see the plots, nicely printed plot, return on the y-axis, risk on the x-axis, covariance risk. You have the frontier points, 25 points along with individual assets, and tangent line, Sharpe ratio line, nicely provided here. So this is your visualization. Also we can also plot the weighted plots and other plots that we discussed earlier. That is quite easy. So you simply need to use the same commands here. We'll just copy paste. In the interest of time, I'll not rewrite them, and I just need to change this short frontier here from box frontier, because this is our box constrained object, box frontier. So I'll just put box frontier here, and again they will be plotted. I'll just enlarge the plotting window a little bit, and then I'll run them. So you can see that all the three plots, weights, weighted returns, and covariance risk budgets are plotted. The interpretation remains same as in the previous series of videos where we discussed the interpretation with target return, target risk, weight contribution of individual assets, weighted return, return contribution of individual assets, how they are contributing to overall return, and how individual assets are contributing to the overall covariance risk of the portfolio, or sort of risk of the portfolio, which is measured through standard deviation or variance. In the next video, we'll plot the group frontier or group constraint frontier. To summarize this video, we created a box constraint frontier object and visualized it. In the next video, we'll create a group constraint frontier object. In this video, we'll construct and visualize group constraint object or portfolio. So first, let us initiate with the group spec, and again, as we do every time, portfolio spec function to initiate the group spec object. Again, I'll use the same 25 points. Here we'll just change the group spec. Notice I'm changing box spec to group spec here. So basically this will assign 25 frontier points to group spec. Now we'll create this group constraints and we'll assign the group constraints. The following constraints are employed. First, we'll use minimum sum weight. That means for assets, let's say 1 to 4, I am putting a constraint of sum equal to 0. Let's say maybe 0.05. So sum should not be less than 0.05. Minimum sum of assets 1 to 4, that means 1, 2, 3, 4. And let me also put a group constraint of max sum W, maximum weight, maximum sum. I'm restricting for asset, let's say 4 to 7 to 0.8. So I'm restricting the maximum sum and minimum sum for 1 to 4 and 4 to 7. So these are my constraints. Now let me define the group frontier nicely. So group frontier, and let me assign it through portfolio frontier function, as we have already done. Portfolio frontier function, I need to specify the data, which is final underscore return. Then I need to specify the spec, which we have created with group spec object. And lastly, I need to specify the constraints equal to group constraints. Now I'll run this command. So my group frontier is created. You can print it to see the elements inside. For example, you will find basic portfolio slot with covariance estimator, solver, optimization function. You have nicely printed objects, the target return, risk, and so on. So let's visualize them. So I'll use again the tailored frontier plot as we used earlier. So tailored frontier plot. For this we need to provide the object, which is group frontier object, and then we need to provide the heading temp text equal to MV portfolio with group constraints, and we'll specify the risk as covariance. Let us run this tailored frontier plot, and as we can see, the tailored frontier plot here nicely printed. Please notice some of the risk return combinations or portfolios may not be available here because of these group constraints as they were in the original plot. Now we can also add those weighted plots. I will simply copy paste these commands. I will not rewrite in the interest of time. And please notice I'll just change the box frontier to group frontier, and I'll put it here. I'll just change the box frontier to group frontier here. As we can see, it is being done, and then I can print it. Notice all the three weights, weighted return and covariance risk budget plots are plotted here. The interpretation remains the same. We can interpret them in our free time. To summarize this video, we started with our group spec object with portfolio spec function. We initiated the object and specified 25 frontier points. Then we provided the group constraints, as we can see here. With these group constraints, we created our portfolio frontier object with group constraints, which we visualize with the help of tailored frontier plot, and then we visualize three plots: weight plot, weighted return plot, and covariance risk budget plots. In the next video, we'll create a covariance risk budget constraint object and visualize it. In this video, we'll construct a budget constraint portfolio frontier. So let's initiate this budget spec, and again we'll use our portfolio spec object. Again we'll set our frontier points to 25, but let's use this budget spec object here, replace this with group spec. So we have budget spec, and then let's specify these budget constraints. So let's start with identifying these budget constraints. Constraint number 1, let's call it budget dot 1, and we'll specify minimum for 1 to n assets. There are 7 assets, so this n assets means 7, and we'll put it to v minus infinite. So this is minus infinite, so we are putting no restriction on the downside. And let's put object number 2, maximum budget constraint. Let's put for 1 to n assets, again 7 assets. We'll have a sequence from 0.4 to 1, and we'll separate it by 0.1. So these are two constraints that we are going to use, and let's define this object as budget. Let's specify this as budget constraints, and we can assign this with both the conditions C budget dot 1 and budget dot 2. You can execute this. In fact, we can print this combined budget constraints. We can print them. We can see here. Now let's create our frontier plot. So for that, let's specify our budget frontier object. For this, we need that portfolio frontier function. So let's specify the data as final return data, then spec as we have already specified our budget spec object. Then we need to specify the constraints. Equal to budget constraints. Let's run this. So we have budget frontier. Now we'll use our tailored plot frontier command here. In fact, we can copy paste the same set of commands, and we just need to replace this budget frontier. Let's replace this budget frontier and we'll call it minimum variance portfolio with budget budget constraints, risk budget constraints. So let's plot this. This is our risk budget frontier, and again please notice a number of points may be not available here which were there in the original plot, because now we are putting this budget constraint, so some of the risk return combinations may not be available with this budget frontier. Similarly, we can also plot the weights plot that we did earlier. We can plot this, notice, with different combination of weights, weighted returns and covariance risk budgets. Interpretation remains same, only that this time around we are putting certain conditions, as we can see here. So to summarize this video, here we initiated a budget specification object with 25 frontier points, and we specified certain budget constraints. As we can see in these lines, we have specified for all the 7 assets certain conditions on their minimum and maximum risk budgets. Then we visualize this risk budget object here. We visualize this through Taylor frontier plot command, and then we also plotted the weighted return and covariance risk budget plots. And we noted that there were some risk return combinations may not be available because we have put certain budget constraints. That means in terms of maximum and minimum risk where it can possibly attain for individual securities. In the next video, we'll create a complex budget object using all these 3 box, group and covariance risk budget constraints, and then construct and visualize the portfolio object. In this video, we'll construct a complex constraint object. We'll employ the group, box and budget constraint objects that we developed in the previous videos. We'll combine them and create a complex budget object and construct a portfolio around it and visualize it. So we'll create a complex constraint object. Let's create that. So for that, let's call it complex spec. Let's call it complex spec, and again we'll use our portfolio spec function to create this object. We'll, as we did earlier, we'll specify the 25 frontier points, but we'll need to change the object to complex spec object here. So we'll do that, and now we'll create our complex constraints, and we'll assign our box constraints, group constraints and budget constraints. So this is our complex constraint object. Now the remaining commands will remain same. We need to create a frontier, box constraint frontier. So let's call it complex frontier. So we'll call it complex frontier, and here instead of normal constraints and specs, we need to specify the complex spec object. Let's call it, we'll use our complex, we'll use our spec as complex spec object, and constraint as, let me enlarge the plot window a little bit, complex constraints object. So this will be our complex frontier, and now while plotting we'll use this complex frontier object to create the plot. We'll call it MB portfolio with complex constraints. Let's plot this a little. We'll need to enlarge it a little bit. So this is our complex constraint plot, as we can see here. So let me plot our complex frontier. This is our complex frontier. Similarly, using this complex frontier object, I can also plot the weight plots, the weighted return plots and the covariance risk budget plot. So let me do that as we did earlier. So this is our complex constraint object. We have weights, weighted returns, covariance risk budgets. Interpretation remains identical as we did earlier. To summarize, in this video we initiated a complex specification object wherein again with 25 frontier points, and we combined all the three constraints, that is box, group and budget constraints. Combining these, we created a complex constraint object and we started with the complex frontier, and we visualized the complex frontier with our tailored frontier plot. As we can see here, this was our tailored frontier plot. Subsequently, we plotted the weighted returns and covariance risk budget plot for this complex constraint plot. In this video, we'll discuss how to initiate a CVAR, conditional VAR or expected shortfall specification portfolio. In the interest of time, we'll only discuss initiation of portfolio, the other functions for generating tangency portfolio, minimum risk portfolio, global minimum risk, equal weighted portfolio, and also creation of efficient frontier will remain same. So we'll, in the interest of time, will not cover that. They can be replicated simply using the functions that we have discussed already in this lesson. So we'll just initiate mean CVAR portfolio. So earlier we were using standard deviation variance, or what we called here as covariance risk earlier. We'll replace that with CVAR, conditional VAR risk. So to initiate that object, we'll simply use this CVAR spec object and initiate it with portfolio spec function. So we have so this is our portfolio specification object. Now notice that while I'm setting the type of this CVAR spec, I'll use the appropriate CVAR risk so that this CVAR spec is created. Now notice that while solver RGLPK has been set, but we'll use a different variant of this and we'll call this set solver command, and we'll pass on the CVAR spec object and specify the solver as sol RGLPK dot CVAR. So this specific solver we'll use this specific solver. Again, the number of assets, although this we have already done, we will assign the number of assets as and call final return. So we specify that there are 6 assets. With this, our complete specification is over. Now you can create number. For example, if you want to set weights or perform other functions, you can exactly do the same commands that you used earlier. So for example, you want to set weights to this CVAR spec object, you can simply assign it with the same command, rep 1 upon n assets comma times equal to n asset. It's the same command. So basically we are able to initiate our CVAR spec object. Now if you want to compute equal weighted portfolio, you want to compute tangency portfolio. As an example, if you want to compute equal weighted portfolio, let me show you that. Equal weighted port equal to feasible portfolio, as we did earlier, same command we are using, and I'm specifying data as equal to final underscore return. Here spec is CVAR spec. Also you can use those dynamic interactive frontier construction with the feasible region and everything. You can do all that. So here I'm specifying long only. So if I run this, my equal weighted portfolio object feasible portfolio is created. If I run this, I can print a nicely printed readable summary. Notice this is CVAR object, CVAR portfolio, risk here being CVAR, and you can see the weights, equal weights. Since it was equal weighted object, we can see the equal weights, covariance risk budgets, target risk, covariance CVAR, and so on. So other procedure and implementation remain identical to what we have already seen. For example, we can construct tangency portfolio, we can construct minimum risk or global minimum risk portfolio, we can dynamically and in an interactive manner we can construct frontier plot as well. So to summarize, in this video we initiated a CVAR object, which was in contrast to our covariance risk object that we created in the previous series of videos in this lesson. So just to summarize, we created CVAR object. The other remaining commands to create frontier plots, tailored plot, and other things remain identical. So in the interest of time, we'll not repeat them. We hope with this lesson and with this R implementation, you are now comfortable with constructing portfolio of your own choice with your own securities using R. To summarize this lesson, mean variance framework relies on portfolio variance or standard deviation as a measure of risk. More recently, tail risk measures such as conditional value at risk, which is CVAR, have been implemented to examine the extreme risk scenarios. We augment our mean variance framework with this CVAR measure to construct and visualize mean CVAR portfolios. We start the discussion with introducing these measures. Next, we implement the portfolio concepts using R programming. We start by downloading the data from Yahoo Finance. Subsequently, we compute the returns and visualize the data. We initiate our portfolio object with simple long-only constraints. Then we construct and visualize portfolios with specific risk return objectives. These include equal weighted feasible portfolio, minimum risk portfolio, global minimum variance portfolio, tangency portfolio. Then we plot efficient frontier in an interactive and customized manner. We also initiate a short portfolio object with box, group, and risk budget constraints and visualize various attributes of this portfolio, including weights, weighted returns, and risk budget composition. We also combine these constraints and create a complex constraint object. We comprehensively examine this portfolio object with complex constraints. Lastly, we also learn how to initiate a portfolio in mean CVAR framework.